Okay, this is lesson 2.1a from Utah Middle School Math Project. We're going to be bouncing back and forth between Utah Middle School Math Project and Open Up Resources. So I'm not calling this officially Unit 2 or Unit 4 or anything. It's just our integers and rational numbers unit. This lesson is specifically about the additive inverse, in parentheses, zero pairs. And it's also the chip and tile model. We kind of did some sort of a model yesterday. Instead of calling it chip and tile, we called it rocks and balloons. You can use rocks and balloons for your chip and tile model because they represent the same things. Other options that you can do as we progress, you can draw an actual tile. That would be our negative because I drew it red. And a positive would be a tile with a positive symbol on it. And those represent the same types of things as the rocks and balloons. Another option, later on in the unit, it will have positives being just a square that's not filled in, it doesn't have any color to it, and negatives are going to be the same square but shaded in. So it's up to you how you want to do it. Since you probably don't want to be switching back and forth every problem with red and yellow colored pencils, you can, but since you probably don't want to, ways that you can do it that are quick, like this, positive is unshaded, colored in is the negative, or positive with the positive symbol and negative with the negative symbol. Or if you really like this rock and balloon analogy that we talked about last class, then you can continue to draw them out like that. So when we're talking chip and tile model, that is what we are referring to. And it says for now, we will use the informal term zero pair. Zero pair is not necessarily informal. Zero pair is still a pretty technical term, but we'll use that focusing on that terminology as we kind of progress through this unit. But really truly, what zero pair refers to are two things that are opposite or that undo each other. When we talk about undoing each other, we call that the inverse. And as you see up here, it's called the additive inverse because we're adding two things together that are opposites that end up creating zero. So you can kind of see how all of those terms kind of come together and relate together. The sum of two elements of a zero pair is zero, hence the name zero. And we see zero pairs in many contexts. Remember, context is a fancy word for in real life or in stories. For example, in an atom with 5 protons and 5 electrons, it has a neutral charge. How familiar are you guys with atoms and chemistry? Okay, so we have had those lessons. Protons have that positive charge. I remember proton is positive because it starts with P. Electrons have that negative charge. And so 5 positives and 5 negatives will have a zero charge because they all zero each other out. With that in mind, I want you to go through these. I'll go through the first two that are worked out, but I want you to try and work out the rest without any extra help. The context or the story is a hydrogen atom has 1 proton and 1 electron. So you can see that they have drawn a model of an atom. The proton is in the nucleus, it's in the center. The electron is floating around the outside, but 1 and 1. So the net result in words, what that really means is we're using words to say what is the final result? It's neutral. You could also say 0. And then the last column, we really kind of figure out, okay, how many zero pairs did we make? Here is that 1 zero pair, and so we write 1. The next one, we've drawn a picture. I took 4 steps forward, and then I took 3 steps backwards. Here's my 4 steps forward. Here's my 3 steps backward. So where are we? What's the net result? I am still just 1 step ahead of where I started, or 1. How many zero pairs? We see those zero pairs. These 3 going forward, these 3 going backward, end up zeroing each other out. There are 3 of those pairs, so 3 zero pairs. Now, this one, probably figure out a different way so that you're not drawing 1 million things. Think about how you can make that nice and simple, but I do want you to draw some sort of a model or a picture. I got a check in the mail for $1 million, but then I got a bill that says I owe $1 million. So work with your groups on that, figure out how you can draw that picture. Just do just this one so I can buzz around the room, make sure we understand, and then we'll come back together. I am going to pause this recording while they work. My favorite one that I saw is something like this, where they actually, very tiny, wrote out a check for $1 million. 1 mil, even better. Then you don't have to count all those zeros. And then they also wrote a bill that says you owe $1 million. It's a good enough model. We can see the check for $1 million. We can see that we now have a bill that we owe $1 million. What's the net result? How much money do you have? Same amount as we had before. Or you can even say zero. It is. Just like it's a big check. So how many zero pairs in this? Yeah, 1 million. It's not just one. Even though I only drew 1 and 1, that 1 represents $1 million that I didn't draw. So there are actually 1 million zero pairs. All right. I really like the next one, but I'm not going to talk about it until you guys have worked through a couple of the other ones. Start drawing those models, start figuring out the net result, and start counting up the zero pairs. Let's come back together. I think probably 3 minutes should be more than enough time. Let's go over this in 3 minutes. And again, I'm pausing the video so students in class can work. Pause your recording so that you can also work on these problems. Ready, set, go. All right, let's talk about number 4. I ate 1 candy bar with 200 calories. Then I ate 4 apples, each with 50 calories. So here's my candy bar, and here's my apples. Perfectly drawn apples that look just like apples, right? Nope, they look just like apples, perfectly drawn, right? Yeah, okay. I thought so too. So what is the net result? Is the net result here 0? No, because does eating healthy calories and apples, does that undo eating bad calories from a candy bar? I wish too. I might eat more apples if that were the case. But no, it doesn't undo that. So what's the net result? We just gained 400 calories. This is our 200 calories of candy bars. This is 50, another 50, another 50, and another 50. So really, truly, we just ate 400 calories. So how many zero pairs? None. There are no zero pairs. Exactly. No zero pairs. I wish healthy food would mean that it would counteract that negative food, but it does, or the bad food, but it doesn't work that way. Joe found 4 quarters. So I'm just doing some samples, drawings that I saw that you guys had done. Here's our 4 quarters. He has a hole in his pocket. So there's my pocket, and there's 1 quarter leaving the pocket. He lost 1 quarter. So what is the net result? What does Joe have now? You can say this a couple of different ways, so I'm interested to see how it's said. Dylan. Yeah, 75 cents. You could also say the net result is 3 quarters, but 3 quarters is also 75 cents. So how many zero pairs? I'm here again. I'm interested to see how it's communicated. Trace. You can say 1 zero pair. If you say 1 zero pair, what are you talking about? 25 cents. What else could you say? Luke? You could say 25 zero pairs if we're talking about cents. I think probably the 25 cents, the 25 zero pairs is probably a little bit more accurate because it was a net loss of 25 cents. It just depends on what our unit is. Are our units actual coins? Are we talking about coins? Or are we talking about value? Lisa earned $8 and then spent $6. I'm a lazy mathematician, so she earned a $5 bill and 3 $1 bills. Aren't you glad that all my money is perfectly sized too? Yeah, I hope yours is too. Is yours just as good as mine? this is what she spent. Maybe I'll have to highlight a different color so that we know that that's what she spent. And the net result here is, I'm looking for hands. What's the net result? Tanner? She has $2. And how many zero pairs then? Grant, how many zero pairs? For zero pairs. Yep, how many zero pairs? Correct, 6. Or 600 cents, yep. Again, it depends on our unit of measure. I like dollars best, but you are not wrong if you say 600 cents. George gained 10 pounds, but then he went on a diet and he lost 12 pounds. You can get pretty creative with these pictures, especially if you're an artist. I am not an artist, but there's my scale with a plus 10. And then here's my scale with a minus 12. So what's the net result? Go ahead, Joshua. Yes, but that's what we mean. So lost 2 pounds from starting weight. Maybe we can clarify and be really math practice 6 precise, very specific. Lost 2 pounds from where he started. So how many zero pairs here? Alexis? 10 zero pairs. John took $15 out of his bank account, then deposited $10. So maybe my picture is going to look like a bank statement if you guys ever get those in the mail. A bank statement where it shows he took $15 out of his account, but then he deposited $10 to his account. So the net result, what's his account looking like right now after all of that? Minus 5. Thank you, Liv. Minus $5 from where he started. Or negative $5. He owes $5. His account has a negative balance. Right. However, this is the information that we have, so this is what we go off of. Okay? If you wanted to say he has $5 less than what he started with, that's accurate as well. And how many zero pairs here? There's another 10 zero pairs. Now we're going to switch gears a little bit. On your homework that you're going to be completing for this section, it is going to be another set of problems just like this. It's going to be on the very back, but I'll let you take a look at that later. Just know that that's what you're doing for your homework. Not too hard, doesn't take too long, right? Let's look at the next one. I told you that what we were going to be seeing is more of these chips, these tiles, and here you can see positives are going to be unhighlighted, uncolored. Negatives are going to be shaded in. Again, I want to emphasize, when you draw your own models, you can draw balloons and you can draw rocks. You can draw a tile with a negative on it. You can draw a tile with a positive on it. How you draw your models is up to you, but I want you to understand this key because when you see models, you need to be able to interpret them. So in each of these models, I want you to figure out what does the model actually represent and then construct an argument to support your claim. For example, I look at this and I see a bunch of positives, so I count them out, 1, 2, 3, 4, 5, 6, 7, 8. This model represents 8. What's the argument? There's 8 positive tiles. Now I know this seems crazy and obvious, but as we progress in some of these other ones, it will make sense why we need to have our argument. This model here represents, let's see, they're all negatives, count them up. So this model is going to represent negative 8. Why? Because there are 8 negative tiles. Now, 11. What does this model represent? What is the number that this model represents? Yeah, this one is 0. Why is it 0? Because we have a positive and a negative, thus making a 0 pair. Exactly. So your argument can be as short or as long as you feel it needs to be. You can simply just say a positive and a negative make 0, or 0 each other out. And for number 12, if I skip to the argument portion, I can see I've got a positive and a negative and a positive and a negative. But then I have one extra positive left over. So this model represents 1. What is the argument? We have 2 0 pairs and 1 extra positive tile. Easy enough, right? Form your arguments for 13 and 14 with your groups. 13 and 14, and pausing the recording as the groups work together to answer questions 13 and 14. Ready, set, go. What does this model represent? Cambria. -1. Why? Exactly. Perfect argument. 2 0 pairs and 1 extra negative tile. And number 14. What does number 14 represent, please? Gideon. Yes, it represents -4. Why -4? Great. 1 0 pair, 4 extra negative tiles. Tying this back into what we did yesterday, I hope you can start seeing some maybe addition problems, how these things are combined, and we're already finding those 0 pairs to form the numbers. In general, explain how you can use a model to represent positive and negative numbers. I'm not going to make you write that down. How do we use these models? What are we doing? Whether it's rocks and balloons, chip tiles, what are we doing? Joshua? Exactly. Finding how many 0 pairs there are, counting what is left over. And so, what I want you to do here, you're creating your own models. You can draw any version of the model you like. I'm just curious, who thinks that they're going to be just drawing blank and then shaded? Okay. Who thinks they're going to be drawing rocks and balloons? No one wants to draw rocks and balloons. Who thinks they're going to be drawing positives and negatives? Okay, great. So you just do whatever you like the best. I am kind of maybe going to bounce back and forth. So it's okay if your notes don't exactly match mine, because I'm going to show a couple of different varieties. Represent -5 with chips tiles in the space below. Well, how am I going to do that? Probably with 5 negative tiles. The next part says, can we represent -5 in any other way? How? How else could I represent -5? Luke? I could. And even though you said such great numbers, I don't want to draw that many of them. So, yep, exactly. Mathematicians are lazy. But what Luke said, I'll repeat for the video, is we can have 15 negatives, 10 positives. The key thing to remember is we always want to have 5 negatives left over. So if I'm going to draw an extra negative, I'm going to have to draw an extra positive to 0 it out. And if I'm going to draw a 7th negative tile, then I'm going to want a 2nd positive tile to 0 it out. Your turn now without any assistance. 17. And then the second part of 17. I want you to represent 7 with chips tiles. And then can you represent it another way below that? With your groups, this should take roughly 30 to 60 seconds. Ready, set, go. Okay, I got my 7 positive tiles. What's another way that I can represent 7? Joshua? Yep. Can be just as simple as that. Could there be extra balloons and extra rocks? Yeah, there can. We just need to make sure that if I'm going to be drawing extra balloons, I'm drawing enough rocks to zero them out so that I'm leaving myself with 7 balloons extra. So what does it mean when I add numbers? We talked about this with our intro to rocks and balloons the other day. When I'm adding numbers, what am I really doing? But isn't any number going to be less than or greater than 0 except for 0? So let's think about back when I had a problem like 7 plus a negative 9. What did I have to do to model this problem? What were we doing? Let's start with something simple. How did I represent this part right here? Luke? I would have how many balloons? And then when we got to this part right here, what would I do with that information? So I'm just comparing it, and so I would just say, yep, 7 is bigger than negative 9. Talk with your groups. What does this right here, what does that mean I need to do? Talk with your groups. Okay, are we ready? When I need to add numbers, if I wanted to add 7 and negative 9 together, what do I do with the 7 and the negative 9? So Luke said we'd have to start with 7 balloons. True. But then what else would I need to do? I heard you talking. I want to see more than one hand, please. I'll just keep waiting. Gideon, thank you. We're going to add some more stuff. Exactly. The word add, it's right there. That means something that is not already in our basket is going to be put into the basket. This is important to acknowledge because it is very different than subtraction. And we're not even going to touch on subtraction until a couple of lessons, but we really do need to understand that add means we're going to be combining something that's not already in there. Add something that's not currently there. All right, so we're going to, I'm not super concerned about us doing these problems just because we spent all of our rock and balloon time yesterday. So I'm not super duper concerned about these ones. We have the experience that we need with adding, whether it's with chips and tiles, rocks and balloons, etc. Let's just quickly, I'm not even going to do 19. Let's just move on to the next section. 20. How am I going to do this problem? We have negative 4, so I'm going to represent that with, watch how lazy I get with this. I'm not even drawing the tiles anymore. There's my negatives, and 4, there's my positives. There's my model. That's the representation. The explanation is that end result is 0 because I have 4 0 pairs. So again, I'm not focused on this section just because of the experience that you guys have with our rocks and balloons from the other day, which means, let me just see where we're at. Yeah, let's just skip over to this next section here. Why don't you do with your groups 25 and 27. Do 25 and 27, model them any way you want, as quickly as you can. And then we'll talk about the homework. 25 and 27 with your groups. Ready, set, go, and I'm going to pause the recording. All right, with number 25, I start with 1, 2, 3 negatives. I'm going to be adding or combining that with 8 positives. 1, 2, 3, 4, 5, 6, 7, 8. In the process, you can see that I have 3 0 pairs, 5 extra yellows, and for the sake of time I am not going to write down my explanation. We have been through this the last 2 days, so I think that we are past that point of explaining. The next one, -5, 1, 2, 3, 4, that's 5 rocks. I am going to be combining it with 1, 2, 3 more rocks. Look at that, rocks and rocks is more rocks. So -5 plus -3 is -8. I have not yet said clean up. You should not be moving around or shuffling. Please take your stuff back out. Your homework, and yes, I know it's homework over the weekend. It doesn't happen all the time, but you are in junior high, so it does happen some of the time. Homework on the weekend. Your homework is this homework section, 2.1a homework, and it is both sections. We have the same type that we did at the beginning with our models, net result in words, how many 0 pairs, and just a handful of those that you need to model. You don't need to explain, you just need to model. You can skip the extension question. All in all, even though there's 16 problems, it honestly should take you roughly 16 minutes. Okay, should not take you very long. That's it. Yep. Thank you for watching. Have a good day.